All right, so the basic assumed knowledge that we require for vectors is firstly the understanding the difference between scalar and vector. So what is scalar and what is vector basically? Uh, so when you look at the general quantities that we express using certain measurements, let's say, for example, like mass, uh, or let's say if we talk about the weight, these are the two, let's say, simple quantities which we talk. So mass doesn't require any direction to be expressed, while weight is always directed towards the center of Earth. So that's why weight becomes vector while mass is a scalar quantity. So scalar quantities are basically that require only like magnitude. We're going to talk about the key terms, so magnitude, and the vectors basically require both magnitude and direction. Magnitude and direction. Now, what is really important, guys, is to firstly figure out how different a scalar and a vector mean. Like, I mean, on a real basis. So if I say that I have to reach from point A to B, okay, so there can be one direct path from here, A to B. I can now go, let's say, use 10 different other paths, and I can still reach to the same point. Now, when you talk about the length of the path that are covered is actually distance, okay? So the length of the path that are covered, and if I add that up, that's my distance. So distance is basically a scalar quantity. Okay, and while when you talk about the vectors, I can use series of vectors to express obviously the same vector AB. But what happened is that it is always eventually give the initial to final point distance. I could have gone like 100, could have taken 100 of other routes to reach the same point, but eventually I am tracing the vector A and B. Now, guys, so as a summary here, um, when you talk about the displacement, the other quantity, which is so displacement. When you talk about it's A to B the A to B straight away edge joining A to B. Now I could have gone like via n different paths, doesn't add up to anything for me as far as I'm considering the vector, because if I am at certain distance, it just the vector is straight away joining those 2 points, a segment joining these 2 points. Now, when you talk about the let's say the distance, guys, which is here, it is about the path length. So you're going to use the two key terms here. One is the distance, other is the displacement in the context to express the vectors. So this is your base knowledge. Now, how do we present vector in like in the IB notation format? So let's say IB asks you guys to know two different things, two notations. One is called as column form. One is called column form, and other is called as IJK notation. So I, J, and K notation. So firstly, let's say, how do we represent the vector in different fonts? So now, guys, let's consider the 2 point system here. Now, if you have the first point is at A here, and the second point is at B, the coordinates are given to us. Now I can go from A to B. That's my vector that I have to find out, and I'll be representing as vector AB. And if I have to go from B to A, I'll be representing it as vector BA, but the arrow still follows the same direction. Now this is the beginning point. This is the end point. You got to be clear about. So now there is other key term that I got to introduce is the something called as position vector. Now what exactly is position vector? So when you talk about position vector, guys, position vector is a vector joining the point and the origin. So here, vector OA is a position vector. And basically, to reach to that point from origin, what vector do I trace? That's my position vector. So let's say here it is 1, and I reach till 5. That's my position vector. If I reach from, let's say, 7 and until 2 up, so that's my position vector of B. So position vector is basically a vector joining that point and the origin. So the same point, like the shortcut that I can tell you is the same point. If I have to write down in position vector form, it will be just write in column form, like 7 units to the right and 2 units up. So that's the indication. Now, Coming to trace this vector here. I would simply say that, let's say I want to find a vector AB. So I'm just going to talk about coordinate of B minus coordinate of A. Now coordinate of B is basically my final coordinate, final position, I would say, minus initial position. So that's how it should be always be there. So final position minus initial position. When you talk about like 7, 2 is my final position. Initial position is 1 and 5. And when I subtract these, I get the vector 6 and -3. So it simply means that I got to go 6 units to the right and 3 units down from this point to reach to here. So in more systematic way, actually, if you see here, what I did is I used final position of B. It means I use vector OB, and initial position was OA with respect to vector. So just guys, remember the shortcut. If you have to find a vector OB, just show this step because this carries a mark. So if it's 2 mark, you get 1 mark less if you don't show this. And then you write down the general coordinates or the vectors in column form. And that's how you find out vectors. Now, as far as the general rule of the vectors is concerned, I'll just kind of show it to you. Let's say if I have vector A here and vector B here. Now I'm tracing back. Let's say I'm going to C, then I'm coming to D, and then I'm coming to A. It doesn't matter that I go from, let's say, I can write on vector AB in different forms. So AB is one way is, okay, I can go straight from here to here. Other form is I can write on vector AB as, I can go from A to C, then C to B. I can go from A to C, and then I can come to C to B. Another way to write on same vector AB is I can go from A to C, then C to D, then D to B, then that's how you get the AB. Another vector is if I know the vector AD by any chance, so that's my AD plus DB. So guys, this is how you find out the general, vector geometry addition and general positioning of the coordinates. Now let's just talk about how do we represent in IJK form. So just to summarize what we did just so far. So as we know that this is, if I have a vector to find out with the coordinates given, I'll just do final coordinates minus initial coordinates. And now just talking about the IJK notation form. So when you talk about 3D, in 3 dimension, let's say you have, so far you have been used to of the X and Y axis. Okay, so this is X axis, this is Y axis. Now then in 3 dimension, you got the third axis, which is Z axis. So now if you move 1 unit along X axis, if you move 1 unit along X axis, we call it as I. If you move 1 unit along Y axis, we call it as J. And if you move 1 unit along K axis or Z axis, that's called K. So let's say here, I can write down the same vector as I moved 6 units along X axis. So I'm going to say 6 times I, and then plus minus 3 times J basically. So it is 6I minus 3J. And I didn't move anything in along the K coordinate, along the Z coordinate. So that is going to be 0K. You can either leave it like this, or you can just don't write this. Okay, so this is how you find out the vectors in 2 different forms. So as far as the notation is concerned. So just have a look at for one of the example for 3 dimension pointing system. So when you have A is 2, -1, and 5, and B is 4, -1, and 3. And in order to find out vector AB, you find out vector OB minus OA. So that's the position of B, position of A. And if you subtract these two, you get 2, 0, and -2. And of course, in IJK notation, you move 2 units along x-axis, 0 units along y-axis, and 2 units along z-axis. So that's how you present it in the IJK notation form. So this is how you do the basic notation and presentation of the basics of the vector.